Okay, so you want to install your own radon mitigation system. We're going to go over the necessary steps to get you to that final safe level of radon in your house if you're having issues. And so the things that we're going to cover in this video, I made a little list here. Designing your system, picking the right fan, purchasing materials, sealing your basement, installing piping and the fan, running electrical, and then any finishing touches after everything is installed. One thing that I want to hit on is I recommend getting a professional to come out and do it for you. There's a lot of steps that aren't very safe. This is an instructional video on how to do a DIY, do-it-yourself radon mitigation system installation. Okay, so if you're ready to install your own radon mitigation system with the safety precautions in place and the education that you have in your brain, let's get started. So, who are you? Can you tell us a little bit about yourself and the company you work with?
I'm Sean Hemmert. I work for Prospect Inspection Services. I've been doing this for about 5 years now. We offer many services: radon testing, home inspections, termite inspections. We do water tests, mold tests, well equipment inspections, basically everything top to bottom when it comes to a house. And yeah, that's pretty much it.
Okay, cool. What are you going to be doing here today for us?
So today we're going to set up a radon machine and we're going to conduct a radon test. Our test typically sits for 48 hours. We use a continuous radon machine, so it runs continuously for 48 hours. The report we provide is going to give you a graph and a chart for every hour for those 48 hours, and it'll tell you what the reading is, and at the end give you an average as well.
Okay, cool. So is when you do the test, is there anything that should be kept in mind in terms of spatial awareness around the device or anything like that?
Yeah, so you want to drop the device in the lowest livable space. So if this basement was like half finished, we would drop it in the finished portion. If there's a crawl space, we just drop it on the bottom floor. You want to keep it basically away 2 feet around it, away from anything, I would say. It's a general rule of thumb. And then you want to keep all your windows and doors throughout the house closed so you're getting a proper test. It can alter the test if there's windows and doors open, wind blowing through and whatnot.
Okay, awesome.
When we first moved into our new home, we wanted to have our radon levels tested. And so we went to Prospect, which is a home inspection company in our area. And the services that they offered were at a reasonable price, and also they offer very professional services. So they have somebody come out and set up their radon equipment and test for our radon levels. It's actually a 48-hour test, and they leave the instrument with you. You're not supposed to touch it, and it basically sits in the area of concern, and it measures the radon levels during that 48-hour period. And so we had our basement radon levels measured, and as you can see, we had a minimum of 1.6 and an average of 8.6, which is 4.6 picocuries per liter higher, or 4.6 PCI over L higher than the EPA recommended rating of radon that is considered safe in your basement. So it's on average higher than the EPA's recommended level. And then we had a maximum of 19 for our radon level. So that was concerning, and we really wanted to reduce the amount of radon in our basement. So we're going to install a radon system shortly. And so temperature-wise, we're around 70 degrees Fahrenheit with a max of 73. And then for our relative humidity, we stayed between 67 and 75% humidity. We do have a French drain in our basement along the perimeter of the slab, so that could be where some moisture is coming in. When you install a radon system, generally you can reduce your radon levels and your humidity levels. So at the temperature of 73 degrees Fahrenheit, we had a 75% relative humidity, so the air wasn't 100% saturated, but it was 3/4% saturated. So that's kind of high. And then here's it every hour. So basically the piece of equipment that they set up tests all this information every hour. They get the air pressure, the radon level, the temperature, humidity. And they do that every hour, and they give you this nice graph at the end of it. And so temperature, I'd say, stayed relatively constant between 3 degrees, but you could see the radon levels were all over the place with the dashed line here. And so we want to get our radon level. If over here is from 0 to 20, we want to get ours like really close to this bottom line here, this horizontal line.
Our radon system is very dependent on the type of situation we have currently at our home. Every house is different, but what we have is a French drain along the perimeter where the wall meets the floor, and the gap is about 1.5 inches. And so we got to fill that gap, got to seal any type of cracks that we have in the foundation or the floor. We got to seal the French drain like I was saying. We have the materials to do that, and I'll show you those materials shortly. And so what we're doing now is we're kind of clearing out and prepping the French drain to be sealed. We're taking stuff out. We're going to prep the surfaces so that there's good connection between the adhesive that is going to be used to seal the cracks. We're going to be putting the fan over in this corner. We have a sump pit over in that corner, but this wall right here is the back of the house, and over here is the front of the house on the right side of me, and then over here on this wall is the side of the house that a lot of people don't see. It's kind of out of eyesight, and that's why I wanted the radon system in this corner, so we can run the pipe towards the roof and it's out of sight and out of mind, and it's not like a blemish on the house. Okay, so what I'm going to do now is I'm going to go around the perimeter and kind of clean, and I might take a blade or a saw and kind of groove out the inside of the concrete slab just a little bit, and I'll bring it closer so you can see. And that is just to make a good clean surface. I might do that, I might not. I don't know if it's really needed. I'm just going to make sure that when I put down the caulk, there's no obstructions in the way. What's going in the crack between the concrete slab and the wall, the foundation, is this backer rod. And the crack here is about 1.5 to 2 inches wide, and probably the same deep. And I'll show you how it looks once it's inside. And so that's going to go in first, and then I'm going to jam it down and then put caulk on top. And that allows me not to use as much caulk, and also allows for a good seal. So this is the box of the backer rod. It comes in 6-foot lengths, and I got 2 inches, and they range in thicknesses. So you just got to search for what you need online or at your local convenience hardware store would have it. Okay, so now what I'm going to come in and do is I'm going to make sure that this crack right here, this French drain that's between the concrete slab and the foundation wall, I'm going to make sure that this edge is clean and that this edge is clean. So once I put this backer rod inside this crack and then I caulk it, the caulk has a good surface to adhere to on both sides. And so this is about maybe like a 2-inch to 1-inch wide gap. So you see here, this is about 1.5 inches. In some places it gets bigger, possibly getting closer to 2 inches. So this backer rod is 2 inches, and so that gives me some leeway. I'm gonna basically shove it down in there and then top it off with caulk, but I'm gonna make sure that the surfaces are clean first. So what I'm doing real quick, it's kind of hard to show with one hand, but I'm gonna use this diamond tipped blade, and I'm gonna go around and I'm just gonna quickly graze this edge here, and that hopefully will remove any like stone that's gonna break off or anything like that. And I'll show you. This is what it basically looks like. Let me put on my eye protection. I'm gonna get a nice clean edge there, hopefully. So it started to get really like dusty in here. You can kind of see it. So I'm just gonna skip sawing this out. I did this basically this whole edge, and it's just so dusty. I don't think it's worth it. So I'm just gonna skip that part. I think it's pretty good anyways. It's not like the concrete down here is crumbling. It has already a pretty nice edge, and you can just do it by hand too. You can knock all this stuff loose if you want to, and I'll probably go around just to make sure I'll have a good contact and there's nothing gonna pop off anywhere in terms of separation of the wall or the slabs. So I started to put in these backer rods, and this is kind of how it's looking so far. And I'm leaving this little bit up right here. I'm also using a knife, just this end, to push it into the crack to the French drain. You can use a screwdriver. I just don't want to puncture the rod. I want to keep it as thick as possible. So the reason why I'm leaving this up, I'm going to put a little bit of caulk between these guys and then push them down, and that should hopefully seal this up. I don't want any air seeping through this guy right here, and then I'm going to put a layer of caulk on top. So that's kind of how it's looking right there. So to put these backer rods in, I've just been kind of lining them up end to end, and then using my fingers to push them downwards as I go. I don't want to go too deep with them. That might have been a little too deep. Okay, so I watched a video on how deep these guys should go, and it's by Sika, and it was a demonstration done by them, and they filled in on top with a polyurethane caulk. And in the video they did a self-leveling caulk as well. They did the one we're using and then the self-leveling caulk. So the one we're using, they said that you should go about an inch down from the surface. So as I go, I'm just going to push this to about an inch down, maybe a little bit less to use less caulk. But what you really want is 2 points of contact, and you don't want 3. So if it was on ground, that would be the 3rd point of contact. But since it's on this backer rod, there's only 2 points of contact, the wall and the surface of the slab here. And so that allows for a lot more movement in this joint. There's probably not going to be that much movement compared to like a driveway or something. So it may not be as important, but that's what's going to happen. I'm going to go around and make sure this is a little bit lower. Okay, so this is what I'm going to be using to fill the French drain on top of the backer rod. It is the BS12S20 standard output, and it's a sausage gun. And the reason why it's called a sausage gun is because the caulk comes in these tubes that kind of look like a sausage, and this is the caulk that I got right here. So it's a polyurethane construction sealant by Sikaflex or Sikaflex. And luckily it's not expired, so that's a good thing. But that's what I'm going to use, and it's because there's a lot of caulk that needs to be put down all around the perimeter. And so I ordered about 30 sausages, and so we'll see how much I use. So people like unboxing videos, so I'm going to also unbox this guy here. It's pretty nicely packaged. It has the different nozzles, it has the gun, it feels pretty sturdy, and then it has this guy too. It looks like it's a different attachment for the back, and it comes with instructions and stuff like that. Subscribe to our videos, you know, okay. So that's what's going to happen, and then this guy just slips right in here, and then I'm going to get to caulking. I'm going to cut this to a good size, maybe like to right about here. I'll cut it off, and so I'll get a lot out quickly, and then I'll work my way with it. So far so good. Okay, so I'm gonna start in the corner, see how it goes. I put down some painter's tape to have a nice clean edge where the caulk's gonna go down. I've pushed this down to about 1 inch deep. I would say more, it's probably closer to 0.5 inches deep. And then in this corner, I'm going to put some caulk here, and then I'm going to shove it down, try and seal these two pieces of backer rod together, and then top it with caulk here, and then continue for a little bit. I only did it up to there. I'm going to use these tin snips to snip the tip off when I put it inside the gun here. This is what it looks like, how much I cut off of the tip here. It's probably 1/2 inch, maybe a little bit more. I'm going to give it a go. Some key takeaways from this. I would, if you're inexperienced like me, I would suggest starting in an area where people won't immediately see it. I started at the bottom of the stairs. Probably should have started behind the stairs, so until I got the hang of it. And then by the time I get over here, it'd probably look a little bit nicer. I think the tape is definitely a saving grace. As you can see, it's going to look really nice and clean. I might put one on this wall here too, to have a nice finish at the top of the wall as well. And I think that would look really nice. This length right here is about 36 inches right here, so about 3 feet. It's 35. And that was one tube, so a little bit over here to the corner. So one tube covers about 3 feet at a depth of maybe like 1/2 inch, and it's about 1.5 inches wide to 2 inches wide. And so I bought around 30 of them. Hopefully I can stretch it all the way around. I'm working with about 100 to 110 linear feet. So hopefully the 30 will last me. So this is how the joints are looking after I glue them together. And then over here, that's another bottle, or another sausage used. And that's another 36 inches about, 3 feet, and I'll keep going. So what I did is I went around the whole perimeter. After doing this little section here, I come to realize a faster way. I went and put some in between every single connecting piece. So between every single 6 foot length of backer rod. And I put them, I sealed between them all around the rest. And then I'm gonna come back and I'm gonna fill in with caulk all the way. And then once that's done, I'm then going to take a piece of cardboard and run over the caulk that was just put down, and I'm going to smooth it out all the way in one stroke, and I'll show that. Okay, so this is how it looks after I laid it all out. Did that all the way down the wall, and I stopped at the corner. So you can see they just look like little bead clumps. And then I'm going to go start this end with a small piece of cardboard. I don't want the tape to come up with it. Get a small piece of cardboard, push down, just like that, and work my way this way with it. I have a lot clumped up here. I might fill up over there, but it looks kind of nice. I might go over it a couple times, but that's the main idea. So this is what the sausages look like when you're done with them. You pop them out. They are stuck to the bottom, and then you just pull them off this cap. Then you just, put the cap back on like that, and then it goes and screws on here. I have about 3 sausages left over, and I'm finished the basement wall. I still have to spread that side out, but for the most part, it's good. You hear them cheering up?
Yep.
Look at it. I'm going to put some of this backer rod around here, and then I'm going to fill the rest in with the polyurethane caulk, and then that should make it less wobbly. What I'm going to do is I'm going to slice this right down the middle so I can, this is a pretty big piece to fit around the base of this tube, and so I'm going to have to cut this guy in half to have it fit all the way around. So I was able to get the backer rod all the way around. And then I'm gonna fill the top here with the caulk. So this is what it looks like. Come around here. It's gonna cover that guy. I'll put silicone around the bottom. Probably use some rubber seals. And then this lid goes on top like that. Cover up these guys because I'm not going to use them at the moment. And then it comes with some hardware, possibly. I'm going to look inside here. Probably some rubber seals, some plastic covers for these guys. And this will probably be screwed into the concrete. And so this lid will be able to come off. This one will stay on attached to the ground. So if you ever need to access this area, you can just take this panel off here and then you're good to go. Okay, so inside here, let's see. Comes with a lot of good stuff falling out. I don't think that's all of it. Comes with the rubber gasket here. And then looks like some covers. Cover. Looks like possibly one cover. Let's see. Possibly this guy. Maybe goes into one of these holes here. Looks like that one. And then cover there. And then I'm not sure there. Maybe this guy. Not sure. But we'll make it work. We'll figure it out. So the plan for this sump pit cover, I'm gonna line it up where I want, and then I'm gonna drill these holes all around using a hammer drill and a concrete screw. I'm going to secure it to the slab here, and then this lid right here goes on top of this cover. And so if you ever need to work on your sump pit, you can just remove the lid instead of having to remove the whole thing from the ground. And so what I'm going to do is I'm going to drill a hole here, a hole on the other side, and then secure it with concrete screws, and then drill all the other holes. And so this way I make sure all the holes are lined, and then secure it. So this is the hammer drill, and this is the concrete drill bit. It came with the concrete screws, or you can buy it separately. Looks like that. And I got it at Harbor Freight. It was under $25. And so it's a hammer drill. I'm gonna line up the cover where I want it. I want it right about there. And then one of these holes here, I'm gonna start drilling, and then I'm gonna do one on the other side. To make sure it doesn't move. I'm going to do the other side. Now make sure that the holes line up. And then I'm good to keep drilling them. You want to go a certain amount past the depth of the screw. So I went around and I used the hammer drill and I drilled in all the holes. I didn't go all the way, I just did a starter. And now I'm going to unscrew the lid. I can lift it, put it to the side. And then I'm going to vacuum all this up, and then I'm going to drill some more. All right, so now that I vacuumed it up and I did all the starter holes, I'm going to go back and do them again. So what I'm going to do is I'm going to apply a generous bead of caulk around the entire perimeter of the sump pump lid. Oop. I'm really going to glob it on. Now that I did this, I'm going to flip it over, and I'm going to make sure that these holes line up with the anchors that I drilled into the ground, and then I'm going to screw it into the ground. All right, so I put the concrete anchors in. Silicone is underneath this guy. I'm going to go around and just do a bead of silicone all the way around the perimeter and smooth it out with my finger. So this is the end result of the sump pit cover lid install. And so depending on when I turn the fan on and how much air is being sucked through these holes here, I might come back and I might silicone around the holes, make sure that there is no air seeping through this lid. I can actually feel air coming through this little hole, just pouring in through this hole out. I can feel that, which is pretty insane.
When we're sizing our radon fan, we have to understand and determine two items. The first item is friction loss. In our system, what is friction loss? In our system, the air travels through the piping, and as it goes through the piping, the air gets slowed down as it rubs up against the sides of that pipe. As it goes through turns, it slows down. So the friction loss of the entire system has to be determined to make sure that the fan we select can handle that amount of obstacles. The second item that needs to be figured out is CFM, so cubic feet per minute. Cubic feet per minute is basically airflow. It's the volume of air over time that moves. So cubic feet volume per minute time. There are actually two other important factors, or two more important factors to consider when selecting your fan. So there's the previous two, understanding the amount of friction loss. The second one was determining your airflow. The third one is what type of subgrade material you have below your basement slab. That is also important, so subgrade material below basement slab. So it could either be a porous material, so it could be stone, like crush and run, where there is good airflow through that, or it could be clay. You know, maybe the person who laid the foundation put it on top of clay instead of what they should have done and used a stone. Understanding your material under will help select your fan, because if you have a very thick clay underneath your slab, your fan is going to have to suck a lot harder. If it's porous and air can easily be sucked through the rocks and taken out of your home. The other one is the area of your basement. So a lot of radon fans can be sized off of the square footage and how large your basement is. So there's 4 total. 4 important design criterias. Our basement is 30 feet by 25 feet, and we want to know the area of our basement slab. So we're going to do 30 feet times 25 feet, which gives us 750 square feet. Here in my hand is a duct calculator. I know this is for medium smooth galvanized duct, but it should suffice for Schedule 40 PVC. I mean, they're both pretty smooth surfaces. The coefficient of friction is probably a little different, but whatever. And so we're going to size it for a 4-inch here, above my thumb here. We're going to size it for a 4-inch pipe, and so I'm lining that arrow up right here. And then we can look at the CFM,
and let's go with 100 CFM. And now I'm just randomly choosing this number. What 100 CFM represents is the amount of air that is going to be pulled out from underneath the basement slab. And so, I mean, if you have a smaller basement, you can go with a smaller CFM. Pulling 100 CFM out from underneath the basement slab, I think that's fine. And we're at about 0.6 inches of friction loss. 100 CFM, 0.6. At 50 CFM, we're about 0.18 or 0.16. And so we're going to use this relationship to determine at 4 inches of round pipe, we're going to use that relationship of 0.6 over 100 feet, because over here it's friction loss per 100 feet. We're going to use this relationship to determine the amount of static pressure from the piping that makes up our system. So we need to figure out how much friction we have, how much friction loss. That'll help us size the radon fan. So what we want to do now is lay out the route our piping is going to take up to our fan and then past the roof. Most states require, I'd probably say all states require, that the radon air that is sucked up from beneath the slab is discharged above the roof. That is so that none of the air has the potential of getting back into the home. So it's discharged above windows, just discharged above soffits that are part of your exterior of your home. So no air can go back in. So we want to go from our French drain that's below the slab out through the exterior wall and then past the roof. So if we route our piping, I'm thinking that the design is going to look something like this. We're going to go from the slab, and then we're going to have a 45-degree angle up towards the wall, and then go up along the wall, and then make a 90-degree angle up outside through the exterior wall. And we're going to make sure that this piece of piping here is sloping back into the house. Because when it rains or when precipitation forms inside of your radon piping, you want it to all drain back towards your French drain, which then drains to the sump pit, so your sump pit can then discharge it outside of your home. So we're going to 90 through the exterior wall, we're going to 90 up towards our fan, and then we're going to come up past our fan, 45-degree angle back up towards the house, and then another 45-degree angle to go up along the house and then to discharge above the roof. Now, what's important is we understand how many joints there are. So here we have 145, another 45, a 90-degree angle, a 90-degree angle, a 45-degree angle, and a 45-degree angle. So we have a total of 1, 2, 3, 4, 5, 6 joints. So we have 6 joints in our system, which is here, 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 and here. The next step is to understand the total amount of length, or the total length of piping in our system and the size. So what we're going to size for is a 4-inch diameter pipe or piece of PVC. And we're going to use schedule 40. And we want to know the total lengths. So we want to know this information here. So let's give these numbers, let's give these pipe lengths some numbers. So let's say 25 feet. And now you can measure the outside of your home. This is probably close to 30 feet. And we're going to work within like 5 feet here. So let's give this 2 feet. Let's give this 1.5 feet, another 1.5 feet. And then let's give this distance where it goes horizontally from outside the home into the home. Let's give that distance 5 feet. And then
this vertical distance, and then this diagonal distance, and then another vertical distance. This distance here is probably about 10 foot ceiling. And this isn't going to go all the way up to the first floor. So this distance here is probably, say, 3 feet. And then this dimension down here is 3 feet. And then this diagonal distance, let's say, is 2 feet, something similar to that. And then we add up all of these lengths to get the total length of our system. Total length. So we have a total length of 43 feet. Now each joint is estimated to have an equivalent length of 15 feet. So one joint equals 15 feet. Equivalent. I think that's how you spell it. Equivalent length. So now we need to know how much additional feet does each joint put on the system. And then that equals 6 times 15. So now we do 6 times 15, which is 90 feet. So the total amount of piping we have on the system is a total length of 43 plus 90 feet, which is 43 plus 90 feet equals 133 feet. Now, what we also have to include in our system is the amount of piping we have under the slab. So if we go back to the footprint of the basement, we have piping that runs all along the perimeter of the basement, something similar to this. Goes along the exterior walls, and then it goes to the sump pit that's in the corner. And then over in this corner here, I'm going to have the drop for the radon system go through the floor. And basically what you want to do is you want to take the longest distance, or go to the furthest point, which is across. So this will be the furthest point here. And you want to use this length because what you're looking for is the farthest run of piping, and this is like the same path of travel here. So instead of taking all the length of piping, so this 30, 25, 25, the air is gonna travel from this point, and it's gonna go down and then out of the hole where the radon pipe goes through the floor. If we have enough power or force to pull air from this point, from this side, we'll have enough power or force to pull air from this direction as well. And so the total amount of added length is 25 plus 30 is 55. So we take the 30 here, 30 plus 25 equals 55 feet added in. And then we take our 133 feet from the previous setup that we had, and we add the above 55 feet, and we get a total of 188 feet. And then from the duct calculator, we know that for every 100 feet, there is 0.6 inches of friction loss. So for every 100 feet, there's 0.6 inches of friction loss. And we want to know how much friction loss there is at a total of 188 feet. And since it's a linear relationship, we're able to cross multiply. Inches water column and then we want to find what x equals. So we're able to cross multiply. And so we get 100x equals 188 times 0.6, and we get 100x equals 112.8, and then we divide both sides by 100 to get x by itself, and we get, the 100 goes away on that side. I should be able to do this. 1.128. So we can round that up to 1.15 inches of water column. So this is basically what we have, the total amount of friction loss on our system. And so we need to select a fan that can handle this amount of static pressure. Static pressure. Let's check out Festa Radon's website. Okay. So here's their website. I really like how it's laid out. Makes it easy for the user to kind of find what they need, fans, accessories, tools. You can learn about Festa Radon and who they are. You can contact them. Contacting them was easy. I gave them a call during the business hours. They picked up, they answered my questions. They helped me select a fan based on square footage, what sub-material I have going on. They offer some resources like finding a pro in your area, things along those lines. So let's check out fans. In terms of fans, what I really like, they're based in Pittsburgh, Pennsylvania, I believe. Let's check out About Us just to make sure. Yep, Pittsburgh, Pennsylvania. They've been in business for 30 plus years. They're reputable. They make high quality fans, and their products are made in America, which I think is great. I'm all about supporting American made businesses. So here are our fans. They differ in prices, sizes, inlet, outlet sizes for the pipes that connect, 4-inch, 5-inch, 3-inch. They have different CFM static pressures that they can handle based on the submaterial, square footage, CFM flow that you need. Now that we have those 4 design criteria figured out, we know our static pressure or our friction loss, which is 1.15 inches of water column. We have our CFM goal of 100 CFM. We know the area of our basement, which is 750 square feet. And then the subgrade material is crush and run or 57 stone or clean stone. And it's porous. So those are the 4 things that we know now, and we can select a fan based on that information. So here are all the fans that Festa Radon offers. We can click on the AMG Maverick, and we can go down and see the fan's description. Okay, there's a 4-inch Burnco couplers that are needed with this fan or should be associated with this fan. We can come over here to the drawing of it. We see that there is a 4-inch inlet and outlet diameter for this fan, so that satisfies our requirement, our math that we did. We can come over here, and under the specifications, the max airflow is 260 CFM. The max pressure is 2.21 inches of water column here, and then we're in the United States, so the voltage is the common 115, 120. And then we have the performance figures, CFM at static pressure and water column. So we wanted around 100 CFM, so we can go down. So CFM is this bottom row here. The top row is static pressure. So we were around 1.15 of static pressure, and then CFM is around 100, it looks like. So this AMG Maverick fan should do the trick. We can check out some other fan options. We can check out the Spirit. So the Spirit down here, it can only handle up to 0.8 inches of static pressure. And then at 0.8 8 inches, you'll only get 26 CFM. So little airflow, and it can't handle that much static pressure. Has a max flow of 121 CFM. So it looks like the AMG Maverick is the option for us. Let's check out the AMG Hawk. AMG Hawk has 6-inch inlet and outlet. So it's bigger. This guy is definitely going to put out more CFM, 322 CFM. It can handle a greater static pressure. We are around 100 CFM here as well. So you can explore the Radon fan page and pick the one that's best for you based on what you're designing towards. Let's see the Eagle. So the Eagle has a 3-inch diameter inlet outlet. Let's see the performance. Okay. Whoa, so this one can handle up to 4 inches of static pressure, and it has a airflow of 19 CFM at max static. So this is going to be for your systems that have a lot of bends in it and long runs of piping, the long lengths where a lot of static pressure is needed to be overcome to see airflow. They have a lot of options here. Check out the Legend. Okay, so this is another 6-inch here. You can also get different Fernco couplers to go from a 6-inch. So it says 2 white Fernco couplers that fit the fan to either 3. Okay, so you can go to a 3-inch or 4-inch pipe from the 6-inch inlet outlet of the fan. You can see a max pressure of 2.5 inches of static pressure. So there's a lot of different options to choose from. So I decided to go with the AMG Maverick. I called Daryl with Festa Radon, and he helped also verify the selection here. I also sent them emails back and forth with questions, and they were very responsive, which was great and helpful. I wanted to take another look at the AMG Maverick. If we go down to their description, read more. The AMG Maverick, we recommend the Festa AMG Maverick for moderate-sized newer homes or structures ranging between 500 to 2,200 square feet, which is exactly what we have. We have 7,500, so it falls in between that range. And then porous sub-slab, such as gravel. So that's what we got. So these are another 2 good reasons why we went with this fan. Now we can go over and kind of can compare some other options. The AMG Hawk has a greater square footage. Porous sub-slab. Let's check out the AMG Spirit. So 1,200 or less square footage, and then a porous sub-slab. And then check out the Legend. This guy has an even greater square footage. So the area of your basement or crawl space and the subgrade material, sub-base material, is helpful when selecting your fan. So Festa Radon kind of lays this out for you, which is super nice. So what I went with was the AMG Maverick Radon fan, and then I asked them to send me an AMG Spirit as well. So I actually paid for almost 100% of the products that I purchased from them. So what I did is I went around to different companies and I purchased the materials, and then I came back and I said, hey, I'd like to show off your products in a video. And so I asked them to send me an AMG Spirit. So I didn't actually pay for the AMG Spirit after contacting them. They were okay with me supporting them and making a video of their company and their products. So they're not paying me to make this video. I just really like their customer service. I like the product. The install of their fan was very quick and efficient. So that was the positive. So I'm going to make another video of the switching out my Maverick with the AMG Spirit, and we can see the difference in CFM and static pressure on the system. And we can kind of see the difference between those two fans. The Spirit isn't as powerful as the Maverick. So I went with the Maverick fan. So accessories, let's check out their accessories. They have a lot of good options here. They have manometer, which shows the system static pressure, or the static pressure your fan sees. They have different couplings. They have a critter guard here. They have a cord kit. If you're going to be installing your fan, say in an attic space, you can actually plug in the fan into an outlet. If it's going to be in your basement, usually, depending on your state, it's hardwired, and that's what I have in my basement. I actually put in an electrical outlet or a receptacle right near the fan, and that's going to be used for like maintenance purposes. And they have electrical components like the electrical box, exterior plate cover or electrical cover plate, and this is so you put a switch underneath this and then you can turn your fan on and off. These are the one-hole pipe clamps that I purchased from them. I thought these clamps were great. I tried a clamp style that's different, a pipe clamp from Home Depot, that didn't really work. These type of one-hole pipe clamps that Radon or that Festa offers allows you to get your pipe away from the siding. So this little lip here, which I'd say is probably like an inch, puts your pipe about an inch off of your siding, which I thought was really helpful. They have a fan mounting bracket, some stickers, some different clamp options. This 2-hole galvanized pipe strap is what I used from Home Depot. It didn't work out too well. An exhaust cap. So yeah, they have a lot of different products here that's worth checking out. I like this website because it kind of has everything you need for your radon system ready to be purchased on this website. It all comes shipped to you relatively fast. So I thought those were all bonuses. It just made shopping for your system really easy. Different tools. They have sump, pump, crock, lid, if you have that in your basement. And if not, you're going to probably just core like I did through the slab. If you have a pit, you can put your pipe right into there and then use these grommets here to seal around that pipe. And then also, if you have a sump pump pipe coming out of this lid, you can use a grommet to seal around that pipe as well. Same with this electrical grommet. So yeah, they offer a lot of good stuff here. They have a gate valve, which can help you control your static pressure that your fan sees and your CFM flow, which is unique. They have the Radon Eye, which constantly monitors your radon levels in your basement or wherever you're having issues, whether it's a crawl space and it connects to your phone. Yeah, they have a lot of good stuff. Makes it easy shopping. They have the smoke bottle, which actually visually allows you to see smoke leaving the bottle and entering cracks into your foundation as your fan. If your fan's strong and your basement's not properly sealed, you actually see the smoke leaving the bottle and going through the cracks. So you can go around your basement with this smoke bottle and kind of test where the air from your basement is getting pulled into the radon fan, which is something that you don't want. So yeah, this is Festa Radon. Made in Pennsylvania, the fans. And then some reviews. So yeah, I like them as well, and I thought I'd promote them here.
Okay, so what we have is the package from Festa Radon, and this is what their box looks like. And it came stapled with copper staples here. I just removed them with a hammer. You open the box, and inside it you have your items. You got your couplings here, one for each side of the fan, so when it attaches to the PVC you can easily remove it if you need to replace it. And then you have different things. We'll go over this later. Cord, brackets, This goes around the pipe, goes up against the siding, kind of makes it look nice. Tubing, and I did get a critter guard. It's nicely made. A lot of people think that you don't need one. And then you have your fan, and we'll show that out of the package soon. I think that's everything. And then stickers. They have these nice stickers that you can label your electrical and also the piping. So
purchasing materials, I put this spreadsheet together to kind of make things a little more organized and simple. So here I have the task of going through the Radon install. And so there's a planning process, the basement ceiling for any cracks, and the French drain sealing, drilling a core through the basement slab, a PVC installation of the system, fan installation, electrical work. So I tried organizing it in the best way I thought possible. I did quantity of the different materials. So under description, I have the different materials here. I have the quantity that I used of each, the unit cost, the total cost after multiplying the quantity by the unit cost to get the total, and then the type or category of each item under the description column. So if it's a product that was used during the install, or if it was a shipping cost, or if it was a tool used. Most of the tools I already owned, but I put the tool here and the cost of it just in case you don't own it. This is how much it'll cost to buy the tools to install the necessary items. And then the overall cost as we go down the tasks. So as I went through the basement ceiling, the cost to get there was around $1,100. After the core drilling, it was around $1,200. After installing the PVC, my cost was at around $1,700, and then so on and so forth. So this is the balance or the cost as the project goes on. So if we zoom into this, okay. So for the products, I did shop around. I got a good amount of products at Festa Radon through their website, and I also shopped at Home Depot and Lowe's. They were right by me. I looked for prices that were the cheapest while still maintaining the quality. So I did look at the reviews of the products as well. And so I kind of just shopped around to get the most bang for my buck while trying to not spend that much to install the Radon system. This list I can attach to the YouTube video in the description section. So this list should be available. You can kind of go through it and see, okay, the polyurethane caulk was used in the basement ceiling. Radon Sump pit dome lid was used, so that was basement ceiling. Core drilling, so I had a tool rental, which was the small core drill, and I rented that from Home Depot. And I got damage protection on it. The PVC install, the different types of PVC fittings that I used, the amount of piping that I purchased, fan installation, the fan accessories and the fan itself, all the electrical work and electrical components that were associated with this installation are included in the electrical section. And then the final radon test was 125, it looks like. Let's see. That shouldn't be 151. That should be 125. That's okay. So services, that was probably for the radon tests. So that's a professional service. So I had 2 radon tests done. So that's $302. And then the total cost of all the products, so that includes the PVC, the fan, and whatnot, that was $1,400. The cost of tools, if you don't own any of the tools, you can expect to spend around $306. The total amount for tool rental, so that core drilling machine, that was $110. And then the total cost of shipping was $144. And so that included the shipping from Festa Radon, and then that also included the cost of shipping the caulk. And so I actually had to make a few purchases. So I could have avoided the extra cost of shipping involved, because if I ordered all the products I needed at once, then that would have saved me some money. But I actually had to make a few extra purchases online, so that added to the shipping cost. So overall, I spent around $2,300 to install the radon mitigation system. What I like to do during projects is I like to purchase as much of the materials that I need as possible, so that prevents me from running back and forth to Home Depot, to Lowe's. This way I can stay more organized and I know where everything is during the project. So if I come across an obstacle or I want to progress to the next step, I have those products there and I have the tools that I need to just power through the project. So I like organizing myself beforehand, knowing the materials that I need, and then purchasing the materials beforehand. When I did this project, I did have to still go back and forth between Home Depot and Lowe's. Of course, there isn't a project where I don't find myself doing that, but I like to try to purchase the materials beforehand.
And so right now we're drilling the hole through the exterior wall. And so we're putting a guiding hole through on this side, and then I'm going on the outside and drilling the 4.5-inch diameter hole that we need for the pipe to go through. And then we have the materials over here. We rented that from Home Depot. Basically, what we're going to use is that tool to then drill a hole through the ground and kind of connect the underground drainage system that is the French drain. And so right now, we're going to drill a hole in the side of the house so the pipe can go through. You can see that the hole was started. That's going to be our guide hole. I just had to remove the insulation and stuff. And so that's our guide hole. I poked through, and then we're going to go on the outside and then drill the bigger hole through the wall. We're going to take that machine, punch a hole in the ground, and you got to do it probably about like a foot or so off of the wall, because underneath these walls is a footer, and so they pour that and then they build on top of it, and that footer comes out sometimes about 12 inches. And then it goes to the slate drain or the French drain, and then that goes to the sump pit. So our goal is to drill through this, connect and clear out the material between the pipe underground and the pipe that's going to come up right here, connect that, and then seal off everything so you have a good underground enclosed area that we're pulling the air from. We don't want to pull any of the air from this basement space. We want it to be sealed. We don't want any conditioned air going through the pipe, because that leads to...
A bad radon installation may not get rid of your radon problem, and it might bring more issues along with it. 1, the radon might still be present. 2, you might cause your home to become negatively pressurized. This results in bringing in unconditioned air through your roof and into your home. It can also penetrate through windows or any cracks that you may have in your home. 3, you might have created the perfect storm. Instead of ridding your home of radon, you might be sucking radon into your home. This is called the stack effect, or chimney effect. This is why in the video I seal my French drain that I have around the perimeter of my basement. 4, some radon specialists believe that drawing air into your home can damage the type of insulation you might have in your attic. 5, a negatively pressurized basement can create a backdraft in the exhaust of any equipment in your home that burns fuels. When this happens, carbon monoxide is pulled back into your home instead of being properly vented to the outside. So if you have a water heater or boiler in your basement that burns oil or gas to heat the air in your home or the water in your pipes, then this is a concern for you. People die from carbon monoxide poisoning. So if you have a radon system installed in your basement and you have equipment in your home that burns fuels, you should invest in a carbon monoxide detector on every floor in your home, just as a little recommendation. So let's recap. An improperly installed radon mitigation system can lead to the same amount of radon being present, higher electric, oil, or gas bills for heating and cooling. More radon is present, i.e. the stack effect. This might lead to damaged attic insulation, and it can lead to carbon monoxide infiltration.
So we don't want that. We want to basically maintain this space, maintain the space underground, keep them separate, and then pump out all the air that's underneath that has all that radon outside. and above the roof. All right, so now we're on the side of the house where we're gonna have the system come out of the basement and up to the roof. If you look at our style house over here in the backyard, there's an edge that pops out and then it comes up and it pops out again. And so that's a lot of 90-degree angles or 40 to 45-degree angles that you have to install. And you want as little bit of turns as possible in your system, and that then increases the efficiency and function of the fan that you install. So if you install it on the side of the house, it's a straight shot up. And so that's another reason. But if you come over here, you can see that this is where the pilot hole came out, or that starter hole that was on the inside of the basement that we were talking about earlier. So now what I'm gonna do is I purchased this guy. We'll go over pricing and everything like that. This is 4.5 inches. And I'm gonna use it to then drill that hole through, and that will then be where the pipe comes through the wall. So yeah, that's it. Now we'll start drilling. Oh, and you need hearing protection. This is aluminum siding, and so we'll see how it goes. If it's too loud for you, Renee, then just let me know. It might be kind of loud. You want to stand over there? So that's how it's looking so far. Come on this side. So it looks like we're going through some insulation. You have the aluminum siding inside. It's going to be a little hot. And then we're going to eventually go through the wall, the wood. Hey, got one. I think you got one. I put an extension cord down there too. Give me one. Thank you. Can you get an extension cord? And we're through! That's how it looks. So now that we have the hole drilled, I cut about a 3-foot section of the 4-inch Schedule 40 PVC to put it through. And it has to be at a decline towards the basement. You want the system to drain basically towards wherever the foundation is, and then you need a way to get that water away. So our way is that sump pit over there connected, it drains into the sump pit, and then it's going to be such a small amount of water, there's no really worry there. We don't have to install a sump pump unless it's needed, unless we see later on that it's a lot of water. I don't think it will be. So the water is draining back into the basement, and so we're going to have it kind of declined towards the basement. The insulation over here that I took down, we're going to reinstall at the end to keep everything insulated. And we're going to make sure it's all sealed and around the piping. If you get close to it, you can see that there's not very much of a gap, which is nice. So it's pretty tight, which is good. And then we'll show you what it looks like from the outside. But the reason why I want to get this done is I want to put kind of all the connections together and see where that down pipe is going to go. And then I'm going to use that to then drill the hole. I'm going to mark it and drill the hole, because right now we're on a 4-hour time crunch. Home Depot allows you to rent the tools for 4 hours or for the day, and they charge you accordingly. And so we have to get this hole punched soon, and we're just going to line it all up. We're not going to seal any of the piping. We're going to do that at the end after we have kind of situate everything, have it all handled and put together. Then we'll seal everything at the end. But this is just so we can make sure it all looks good and functions the way we want. So it's going to come in. It's then going to do a 90, and then it's going to come down to a 45, and then another 45 straight down. And this is so you can be out from the footers, close to the drain that's underneath, and then it goes close to the wall and out. Again, you want as little turns as possible, and this is the best design that we could think of. What you're going to do is going to hold this, and then what I'm going to do is I'm going to use this guy right here. I cut this piece so it's longer than this, because what's it's going to do, once we drill the hole, it's going to go into the ground, and then I can push it back into the top here, and we can seal it that way. So that's basically the reason why it's longer, and that's how we'll kind of put everything together. We'll take it apart, seal it, and then do that. But right now, we got to make sure the hole is right below it. And it's okay if it's a little off, but you want it to be pretty much plumb. If you have a plumb bob, that would be great. We don't have a plumb bob. If you don't know what a plumb bob is, just look it up and maybe buy one. But what I'm going to do is I'm going to stick this in front. I am then going to use a level and a smaller piece. I'm going to set this piece behind it, and that should be kind of right below, just like that. What I want to do is I want to make sure that this is level here, and then this guy's going to come up to meet it, and that looks pretty good. And then you can check this side, just like that. Just to come over just a little bit, looks a little crooked. You want it to be right on, something like that. And then you can line up the piece right below it, and that should be pretty good. Doesn't have to be perfect, but you do want it to be as aligned as possible. And then, can you hold this for me as well? And then you can take a step back and kind of eyeball it. See if it looks good. Yeah, looks pretty good. All right, so what we did here is we then traced out a circle of the PVC. This is a drill bit, but it's 5 inches in diameter. PVC is 4.5, so we have some wiggle room, which is nice. Just like that. We'll use the machine to drill the hole. So all we did here is set it up. We're gonna turn this shop vac on. It's connected to a box. Hopefully this will contain most of the debris and smoke that comes off. You shouldn't breathe in concrete dust, it's not good for you. The state of California says it's, I don't know. So we traced out the hole, we lined it up. We feel confident. We're gonna drill. The slab is hopefully about 4 to 6 inches thick. And we're just gonna keep going. Once it breaks free and you feel it, then stop drilling and then start taking out the debris. Don't keep pushing down. You wanna see what's underneath the slab before you push past it. So that's just a little bit of advice. So we're gonna turn on the vac. We'll show it up close. You have your hearing protection, your breathing protection, and your eye protection when you do it. So I'd say we're about halfway.
After we drilled the core through the concrete, I actually looked up a video. I should have done this beforehand. I watched a video of how to properly core a hole through concrete, because the way we did it was not correct. So drilling a core through concrete slab. So a lot of the times you can use water to keep the concrete dust from getting into the air. And so let's watch a video here, and the proper way to drill through concrete. So they're set up, they have a stand that they're going to use. They're going to actually drill into the ground to set an anchor. So they're going to clean out that hole there. They're going to set the anchor, and then they're going to actually secure the stand to the ground. So this keeps the drill from wobbling. They're going to hook up their water, the machine. They're going to use that hand crank there once they turn the machine on, and they're going to apply pressure downwards to the concrete slab. And so that water then will prevent dust from getting into the air. It's a little messy, but if you have a shot vac, you can then clean up the water afterwards and dispose of it that way. The hard part about this, you can't just dump concrete water outside, and you have to find a way to dispose of it because of the materials that are now in the water. You shouldn't dispose of it all willy-nilly. There's a proper way to do that as well. So the way we did it is not proper. It was also a little unsafe, probably not good on our electrical circuit that drill was on. You saw that the power kept shutting off. So this is the proper way to do it, and I suggest doing it this way, using the drill stand.
So this is what it looks like on the way out. This little bit made it a little complicated to get out of this hole. But if you come over here, this is what it looks like inside. You can see that there's a tarp. So underneath this is rocks, which is a good thing. That improves the efficiency of our fan's suction, because sucking through rocks is a lot easier than sucking through clay. There's a lot more space between the rocks. So we're going to utilize the system that's right underneath here, and we're going to install the pipe. If you look here, we wobbled a little bit, and so hopefully we have enough play in our system with the piping where we can make it still function properly. So we got to dig this out now. All right, so what we're going to do is we're going to take the stone out of this hole. We actually were a little bit too close to the wall. You can see that the footer right here, but we still got some room to work with in terms of making a good digging out a lot of stone underneath this portion over here, so we can still get that amount of space, that volume underneath this slab to suck out. And hopefully, you know, seeing this stone here, it allows for better airflow underneath. So hopefully the system will still function the way we want it. You can see the connection here. It's pretty straight. It looks pretty good. I'll come around this way. Looks pretty good. And it did shift a little when we were drilling. You can see here. You can see how it wobbled a little bit, but we got a good amount. And I'm going to secure that. We're going to put some backing rod in there and then caulk it. And we're also going to secure it up here. And we're going to seal everything. And right here, you can see we've started to dig out some of the stone. We're going to dig some more out. Maybe we'll find the pipe, maybe not. Who knows?
Let me see. Hold on. Let's see if I can see it.
All right, so what we
Oh, you can see it.
What we discovered is the pipe. We found the pipe. It's right there. Yeah. Can you put your maybe you can't. It's like right in the. Oh, there it is. There it is. So we found the pipe and we can connect to it. That's wonderful. All right. So what I'm gonna show you is the pipe. There it is. What it looks like underneath the slab. There it is. There's a good gap underneath. And we're going to cut a hole in the top. Okay, here's the first attempt at cutting a hole. It's not that big. It's probably like 2 inches tall, 4 inches wide. My goal is to make it a little taller. Now that we have the hole dug out and a hole cut into the pipe, and you know that's the amount of rocks we were able to take out, we're now going to seal and connect all the pipes. And we actually bought some pipe metal straps to support the pipe and hold it up against this wall. We're gonna take this guy and do something like this. Okay, so now what we're doing is we're gluing the pipes together, and we already glued this section of pipe, and I'm just gonna run through real quick how to do it. We glued the top first because this beam here, or this runner, whatever it's called, is in the way, and so we have to start at the top and then work our way down. And now we're getting to the last bit of piping connection inside, and what we're going to do, we're going to take this 45, we're going to put it on this long piece, and then put this long piece into the hole, and then connect it onto the already assembled pieces that we have here. And so the products that we're using a primer right here, and then we're putting on the cement right here. And what we're doing first is we are, wherever it is, it's right here, we are sanding any burrs that are caused from cutting. And burrs are like little pieces of plastic that are remaining stuck on the edges. You don't want any on the inside, you don't want any on the outside. So we're going to sand it down, which we already did. And then we're going to apply the primer first on the on the outside here, and then on the inside of here, and then the cement second layer, and then stick them together and hold for about 15 seconds. No, I should be better with my words. I don't want to weak down the side, so I'm going to keep it down that way. Okay. And I'm going to do that side, and then that side, and then put it together.
Do you want me to do it?
No, it's okay. But can you do that one? Yeah. Or you want me to do it? Oh, yeah, cool.
That should go very nice.
Mm-hmm.
Okay, this way.
That's it. I just cleaned up the rocks that we dug out of this guy. I put it in a bucket. I'm just going to take it outside and toss it in the woods. There's woods behind our house, so I'm just going to do that. Okay, so what we did as it exits the house, we put a brace around here, so it's not going to pull away from the wall at all. This is me yanking it pretty hard, and it's stuck on there. So I feel pretty confident that it's not going anywhere. You know, it might shake a little this way, but we're gonna try and fix that as we go. So I put in another brace going across here, and I drilled concrete screws into the sides, and it's pretty good up top here. So what we're gonna do today is we're gonna focus on the piping, installing the fan, going up the side of the building here. This is how we left it for about maybe 3 or 4 days. We just capped it, and we're going to use this. This will be a piece that we use here. But we're just going to assemble this and then install the fan. The electrical will come later. It'll probably come out the side right here, and we'll get to electrical another day. So what we did is we dry fitted the PVC, and you see we have a Y piece here. So when the water comes down the pipe, because there's going to be condensation and then also rainwater, it's going to go into this. We're going to drill a hole here and then connect these two pieces of PVC and bypass the fan. So all the water doesn't go into the fan. Some people will do the fan in line with the downspout, and the water will go into the fan. And this is just to prolong the life of the fan. You can get, I've heard, 1 to 3 more years out of a fan if you have a bypass. And so that's what we're doing. We're going to connect these two pieces with a smaller tube, and then we're going to insulate that tube as well. So we dry fitted it. We're going to come over here. We're going to cut the piece off right here because it's too long, and then we're going to put a sweep, a 90-degree sweep adapter, and then connect it to this fan. For these pieces right here, we've been using about 5 inches sections of PVC, and that's what we've been doing along this piece, and we're going to do it at the bottom right here too. These couplings are used to easily remove the fan if there's a problem with it. If it's broken, you need to replace it. So that's why these are important, these types. You don't want to seal it into one piece because then you got to cut it all apart, and it's a pain in the butt later. So that's what these are used for. We're going to make sure that this piece here is sloping into the house, so the water slopes this way and doesn't pile up here. It won't, regardless. It's not like we have a I forget what that's called in plumbing, where it goes down and then back up. That's not gonna happen. There's not gonna be piling water, in my opinion. So you won't hear gurgling. If you hear gurgling, that's water built up and the fan's struggling to suck the air through. So if you have that issue later on, that's what's going on, and you just need to figure out a way to divert the water flow. But that's what we have going right so far. We're gonna seal all this up, cut the piece, put it all together, and then run the tubing up the side.
How did you like perfectly line it up? That's impressive.
Nice.
You are nice.
Okay, so you just want to make sure. We couldn't place it directly on this pipe, but but you just want to make sure it's sloping towards the house. So the bubble is on this side. That's good. So in retrospect, what I wish I did, I wish I moved this hole over a little bit to in line with the studs going up the side. Usually they run every so often. I don't know what the dimensions are. I could always check the attic. Up top here is where the attic is. I could always look at the attic, see where the studs are, and then work my way down. So I could drill directly into the studs with the supports, the clamps that I have for this post here, the tube that runs all the way up. But what I'm gonna do, since I don't think I'm in line with the stud, I'm gonna put an extra stud in the attic, most likely, to screw into. I'm gonna screw into this second floor runner that goes this way here, and then I'm gonna do one in between and one down here as well. The siding of my house isn't made out of sheathing. It basically goes aluminum siding, insulation, membrane, and then I think an insulation board. And so it's not very sturdy to drill into or to secure things to, as opposed to wood. So in retrospect, I wish I lined it up with a stud so I can drill the clamps into it. Okay, so what we did is we took a chalk line and then kind of used it as a plumb bob to make sure that this pipe is going to be straight up and down, and then we snapped the chalk line, and now we're going to go up and we're going to drill the clamps into the side. And I'm going to go for one at the attic, one at the second floor, and then one in between each. So I fully assembled the top part. You have your screen here that stops debris and animals, a critter screen from going down the pipe. So I assembled it down here, and then I'm gonna just walk up the ladder and then put it in the top of the tube, connect the two tubes, and secure that last bracket at the top, and then the chutes should be good. One thing to note is I didn't secure this critter guard onto the actual piping, so if I ever have to get inside this guy from the top, for some reason, I can just take this off, but I shouldn't have to do that. I shouldn't have to go on the roof and go inside. So we ran the pipe all the way up, and the pipe is up against the house now. You can see that it juts out a little bit at the top where the shingling is. So we put 245s on there to get it away from the house, and then we ran it down, and we used 4 clamps, and there's a little bit of movement. I'm shaking it now, but it's pretty good, pretty solid. And then once it's connected to the fan down here, it'll be even more solid. So I'm gonna reassemble this here because the fan was a little crooked and I didn't like that. So I wanted to make it more so the fan is level. And that's that.
What I did here between the left and the right pictures, the two different setups, the left was how I originally had the setup when it was first installed. I sealed everything and then ran the pipe. After I ran the pipe, I realized that the fan was crooked. It wasn't lining up properly in terms of it being horizontal. You want the fan to be level. And so the left side was a little crooked, it was off, and then it was also pulling away from the siding. So that Y piece that connects the vertical pipe to the fan bypass, that Y was actually too short. So I had to extend that connection from the fan to the siding because the pipe was being pulled away from the house. So in retrospect, what I wish I did, I wish I just dry fit everything on the outside, ran the vertical pipe, and then sealed everything. Because what I had to do is I had to run back out to Lowe's or Home Depot, wherever I got the fittings and the PVC pipe from, and then I had to reassemble everything. So it was an added cost, and I wish I didn't seal the outside. So you can see that the fan also has above and below where the inlet and outlets are a larger or a greater length of vertical piping where the coupling meets the PVC. So you can slide the PVC couplings up and down to remove the fan from the setup if you need to replace the fan. So the left side didn't have as much space to move those couplings, and it was more difficult to get that fan out. The right side has more space to move the couplings to remove that fan. So that's the difference between the two setups here.
So what I'm going to do now is put a lot of silicone all around here, all around the bottom. Same for this guy. I'm going to surround with silicone, and just put a lot of silicone and then slide this back into place. You can see how I just globbed a whole bunch of silicone on there. I'm just going to push this guy right back. So I just drilled this hole right there, and I'm going to put the threaded end in here, and then the tube, the drain bypass, will be on the barbed end. And I already have the one fixed up right in the bottom of here. So I'm finding that hand tightening these guys, instead of using the ratchet, is a lot easier to get them to stay straight up and down, as opposed to using this and then it tilts off sideways or anything. So hand tightening it slowly is the best way. So this is what it looks like on the inside. I'm gonna caulk around here, and then when it rains, all the water will go through this hole, through this tube, and then bypass the fan. So this is what it looks like. And it's pretty sturdy. I'm shaking it right now. Feels pretty good. Now I'm going to put this insulation around this guy, and so when the rain comes down through this guy, or the condensation that forms inside the tube, as it drips down through the bypass, this will stop it from freezing, or hopefully stop it from freezing when it gets too cold out, because this is really thin, and so it's more likely to freeze, and then as it comes down, it'll freeze over on the right side, and then it'll just come down through the fan. So hopefully this will stop it from freezing. So for this guy, usually what you use this for is when your radon fan is located in your attic, you're just gonna wire directly into the fan box. You're gonna connect these wires in there, and then you're gonna, if you have an outlet in your attic, you're just gonna plug the fan directly into that outlet. It doesn't have to be hardwired. This is usually customary when you're doing work in the attic, as opposed to having your fan located outside. Traditionally, you just have it hardwired.
Before doing anything electrical, remember to turn off that circuit in your circuit panel, turn the breaker off before working on anything electric.
So I decided that I'm going to put the socket up high. There's 4 dots in the back, and I just used a pencil to mark where I'm going to drill the holes. And I have screws that are meant for concrete, and it'll hold this box here, and then the wire will come down through the top and feed a receptacle or an outlet, and then that's where the fan will plug into this guy, and then it's gonna come over here and attach to this light right over here. Just drilled the 4 holes for the electrical outlet box or the receptacle. Now I'm gonna use the vacuum, and I'm gonna suck all the concrete dust out of these holes, make it so that there's a good surface for these screws to attach to. So I just put the concrete screws in, and it came out a little crooked. You can see here. I'm satisfied with it. I wish it was a little straighter, but that's how it is. So what we're gonna do next is we're gonna take the wires, we're gonna run the wires from this receptacle that we're going to put in the box we just installed on the wall, and then the line here is going to attach to a light on the ceiling, and so that'll then power this outlet. And so I'm gonna
take this casing off to about here, maybe 8 inches or so, and then there's 3 wires inside of this casing. The black is going to be your hot wire, then the middle one, the copper one, is going to be your ground, and then the white one is going to be the neutral. And so on here you have where your hot wires will be attached to, your neutral, and then your ground is this one at the bottom, the green one. After many attempts, I got it to look something like this. And so I took it about 1 inch to maybe 1.5 inches down. This copper wire is the ground and it's already exposed. This is how the bottom looks. Now I'm going to take the casing off of these black and white wires. So this tool right here, it has 14 gauge and 12 gauge. And so I'm going to use the 14 gauge hole because this is 14 gauge wire. And I'm going to remove maybe about 1 inch or so of casing. Just like that. Do the same thing for the white wire. Just like that. So now what I did is I bent the wire with pliers, made like a little hook at the end, and I wrapped it around the screw, and I screwed it down. And so this silver screw attaches to the white wire, which is your neutral, and the green is the ground. And I did the same thing. I made a little loop on the end, and then I pinched it, and then screwed it down. And I did the same thing on this side right here for the hot wire. Made a little loop, and then I screwed it down. And now it's ready to go on the wall. Okay, so now we're gonna talk about this piece. It comes into 2 pieces, and it screws off of the bottom, this washer. And so you go up here, and this guy gets inserted into that hole there, and then this washer goes on the bottom. And so the wire comes down and into the box and attaches to the receptacle, and this guy holds the wire in place. And so the wire can't be pulled off of the receptacle screws, and it's just to secure it. So there's no movement of the wires inside of the receptacle box. So this is what we have. We have the receptacle, the wires coming in, it's all attached. We have the washer, we have this guy up top here that gets inserted into this hole, and this guy's job is to hold the wire, secure it to the receptacle box so there's no movement of these wires attached to the receptacle. And then this screw goes into this hole, then this screw goes into this hole down here, and then the receptacle is attached to the box as well. When you secure the box to the wall, to the concrete, using the concrete screws, make sure to hand tighten them when they get close to the wall, because you don't want to torque off the head of the screw. I finished screwing this in. Making sure I want to make sure that it's straight up and down. Right now it's a little crooked, so I'm going to fix that. So there it is, nice and secured to the electrical box. Now I'm going to put the cover on this hole right here. This screw goes into. So the receptacle box is done. It's not going anywhere. Awesome. Now I plan to use these staples here to secure the line, the wire, to the wood. So I'm going to use the staples and go all the way around here to attach to that light. I have the receptacle here. I made like a loop here of extra wire in case this ever has to be moved. Hopefully it doesn't. And then it comes across here. I've secured it with staples. See the staples every so often. It comes over here, and then I'm going to wire it to this light right here. We're going to
connect the outlet over there to this light. I have to turn off the power for it. I have this lamp and it's connected to this battery here. And so when the power is off, this lamp will still run and we'll be able to see as we connect the wires. We're gonna be using this guy right here. You can see it. That allows us to connect 3 wires in, and so we'll be able to connect the light and we'll be able to connect the outlet. So we're gonna use these. Okay, so here we have the clips. They're just slip-ons, and you insert the pieces in like that. And so these smaller wires will be what we connect to the light up above. And so this is how it just connects. So you have your wire and you just slip it in. If you want to get a good angle over here, like this. You just insert it and it pushes in and it doesn't come back out. So I'm just prepping it before I have to turn off the light. And then I'm gonna finish it off by wrapping some electrical tape around each one to hold the wires in place as well. And so these ones will go to the light, and then the main power cord, or where the wires are coming in from the circuit, the existing circuit, are gonna go into this third hole here. And so that's how it'll all be connected. So even though this light is off, the receptacle will still be functioning. So right here we have our 3 wires coming in. We have our black, which is our hot, our white, which is our neutral, and then we have the copper one that's exposed, and that's our ground. And so we're going to connect it to those. Those ones that are existing are going to be inserted into those clips. So what I did is I cut the ends off, and then I removed the casing on them. So I wanted to start fresh. I didn't do anything besides unbend the copper one. So now I have clean connections on these wires. All right, now what I'm gonna do is I'm gonna connect the new wires to the 3 screws here. So I have all these guys attached. There's 3 slots, and you can see the wires all the way in and secure. That's what you want to see. And then the 3rd wire is gonna go into the ends of the rest and make sure the colors match. So what you have to do is feed this line through the light fixture and then into this guy, so you can connect everything inside of here. And then all this extra I'll kind of loop up over here in case there needs to be any wiggle room. So these are the other 3 wires that are gonna go into each one of these. So now all of them are attached. I'm going to wrap these in electrical tape, and then we're gonna turn on this light and see if we have power. Okay, so the light is working. This is just a check. We're gonna turn the power back off and then wrap everything in electrical tape and then secure it. Okay, so the wires and the connectors were wrapped as best as I could. So what's going to happen next is I'm going to install this gang box on the outside. This is going to be the shut-off switch, and basically I'm going to make a mark where this hole is, and then I'm going to drill through into the basement through the exterior to the inside. That's where the wire will attach to the switch here. I used a 3/8 bit to drill through, and I'm going to try and fit the wire through, and then if I can't, I'll bump it up to a 1/2 inch. I'll let you know which bit size is best. So the 3/8 size worked really well for the wire. I wanted it to be pretty close in terms of size, but when I put the gang box up against the house, the back I'm gonna have to cut out just a little bit wider so I can fit this piece that I'll show you in a little bit into the siding to make the box flush with the siding. So this is what I'm talking about. This guy is going to hold this wire nice and steady up against the house so it can't be pulled out of this box for some reason. So I'm gonna put this up against the wall, but as you can see, it's not flush. So I'm gonna cut out just basically a circle big enough around the wire and into the siding so I can push the box flush up against the house. And then I'll probably put some silicone around it. Now the box will be able to sit right nice and flush up against the siding. So as you can see, the socket acts as just a connecting box. So the line from the light on the ceiling comes in. So the wire comes in, connects here to this WAGO type connector, and then it connects to the fans line that goes out, and then it also connects to the receptacle. So I ran the wire through the inside of the house out, and then I'm gonna feed it through this box, and then when the box is up against the wall, I'm gonna tighten these guys down, and then insert it into the circle here, and then screw this box into the wall through these holes here. There's another one down at the bottom. I'm gonna put screws through those two holes so it'll be secured to the house and it'll be nice and tight to the wire, and then I'll be able to install the switch. So what happened was, when I tightened this up, this wire wasn't getting snug inside of this clamp here because the gap was too big. So I fit another of the same size wire, just cut a little slice in there about the same size as this clamp, and I put it in and I doubled up the wires basically just for this clamp, and it's holding it really well. So I put some caulk back there now. I'm gonna add more eventually to both sides, but there is some back there right now. So I put in this adapter plug here. It's called an adapter bushing. And so this box is 3/4 inch holes, and then this plug is a 1/2 inch hole, which fits this connector right here. And so this is the connector that encases this wire in tubing. Okay, so what I did is I ran the wire inside of this tube up to this 90-degree fitting here, and I fed the wires into this box. And there's these 3 WAGO-like wire nut lever connectors. So the wire comes in from the gang box and comes in through here. Now this is a joint that locks off inside here. There's a little nut that secures it. You can see it there. And so this 90 comes into the box and makes a watertight seal. And then you connect the fan wires with these wire connectors to the positive, ground, and neutral wires. And it's very simple. You just feed the wires in, slide the wires into the wire lever connectors, and then just secure the wire. So it's just a lift up type and push down wire connector. Pretty easy, pretty simple. And then that's it. You put the wires back in, and then you put the lid back on, and it's good to go. Instead of securing the box through these holes on the side here, I went from inside the box. So I put a screw in right there and a screw down at the bottom. You can see it in the back there behind the wires. And so I thought that would be better. I feel like it would be more waterproof than doing it from the outside holes on each side. And then we joined the wires together. So we had to go to this switch from inside the house to this switch here, and then from the switch down this tube and then to the fan. And so there's, in a sense, 2 sets of wires here. There's from the inside of the house to this gang box, and then from the gang box switch down through here. So there's kind of two sets of wires, and that's why you can see the twists in here and this 3-wire connector here. Okay, so this is a disconnect switch right here, and it's basically used for maintenance. If you ever have to do anything to this fan, you can turn off the electrical connection to it, the power going to the fan. You can turn it off right here. It is on, and now it's off. So you can hear the fan dying down, barely. And then if you want to turn it back on, there it is. You can hear the fan coming back on. So when you install your manometer, you want it on a straight chute, and so I chose this area right here. It's up and out of the way, especially if you have kids. And I drilled the holes where the screws will hold the manometer to the tube, and then I will take these caps off the top. So now that the tube is secured nicely on there, I hand tighten these screws in, making sure not to crack this plastic piece. And then next up is installing this tube, and so one end goes here, and then the other end you drill a hole into this tube here, and make sure to go at a downwards angle, so if any condensate or rainwater drips down this tube, it's not going to drip through this tube into your manometer. And so we're going to drill downwards at an angle, and so this end is going to be connected into the 4-inch pipe. Also, when you set up your manometer, you want to make sure that the 0 lines up with the tops of the liquid. And so right now there's a gap. I can actually push the bottom upwards, and it should slide to where now the tops of the liquid is at the 0. So what I did is I fed the tube, and you can see it's right here. I don't want to put it too far down this tube because you don't want your radon fan to suck all the liquid out of the manometer. And then this hole is angled downwards, so the tube goes in and then into the top of the manometer. And this guy can slide out. Some people will caulk this, but it's a pretty tight fit, and so I'm not going to. And then some people caulk this so it doesn't come out, but I feel like it's fine. So we just turned the fan on. We can hear air going through the pipe, and then we could also feel the fan running outside. It's actually pretty quiet. The manometer is right a little bit under 1, and so my math, I was aiming for 1, and I'm pretty happy with that. So if you're ever going to do maintenance on your fan, you're going to turn the circuit breaker on the panel board in your house. You're going to turn that circuit off, so then you can do maintenance on your fan. You can work with the electrical here. And then if you ever want to test if the electrical is on, you have your tester here. This is from Klein Tools. And so what you can do is you can bring it over, and then if there's any electricity running through the circuit, it should turn red and beep. Yep. So there's power going to it, so that's how you know. Also, the fan is running, but just double check before working on anything electrical that there's no power running through those lines. So I got these stickers, labels for the radon system, and I labeled the circuit that the radon fan is on. I also put a sticker on the receptacle that the radon fan is directly connected to. I also put a label of the direction of the radon flow. I'm gonna put this sticker on the sump lid, just letting everyone know that the lid plays an important role in the radon mitigation system, and so it's to make sure that the lid stays airtight. There it is. I'm also going to use this sticker here. I'm going to fill it out. Installed by homeowner, date when installed. There is no license. I'm not going to put the phone number. I'm going to put the estimated cost per year.
Let's talk about how much the fan will cost to run yearly. We know what the amperage draw, the power draw of the fan, what that is. Festa Radon gives us that value. For the Maverick Radon fan, the amperage draw, the power draw for that is 0.61 amps at a voltage of 120. They have 115, but we can say 120 because there's some variation in the voltage. Just like a light bulb, light bulbs have a certain wattage. This one in particular is 15 watts. And what we need to find is the wattage of the radon fan. So in order to find wattage, we know the formula P equals IV, where in this case P is power, represented by watts. I is current, represented by amps. And then V is voltage, represented by volts. We're trying to find power. We know the radon fan is 0.61 amps, and the voltage is 120 volts. So power equals 0.61 amps times 120 volts, which gives us 73.2 watts. Now, to find how much it will cost us per year, we have to get the wattage to kilowatts. Most delivery services, in terms of your electrical company, will give you your charge in kilowatts per hour. So we need to eventually get from power, watts, to kilowatts, then to kilowatt hours. Kilowatt hours is just the power multiplied by the amount of time the fan will be running, which is 24 hours a day. In order to get from power in watts to kilowatts, we have to divide this number by 1,000, because there is 1,000 watts for every 1 kilowatt. Kilo, K-I-L-O, is just 1,000. So it's basically saying for 1,000 watts, there's 1,000 watts. So we divide the wattage here by 1,000. So 73.2 watts divided by 1,000 watts equals 0.0732 kilowatts. Now that we know our kilowatts, we're going to determine what the kilowatt hours are for this fan. So it's going to be running 24 hours a day, 365 days a year. So we want to know what the kilowatt hours is. So we have 0.0732 kilowatts, and then we multiply that times 24 hours per day. That's for 1 day. Then we multiply that again by 365 days in 1 year. And we get 641.2 kilowatt hours per year. This is how much power we're using for the radon fan
running it nonstop for the entire year. In my area, the electrical company charges us per kilowatt. The charge from our electrical company charge is 8 cents per kilowatt. So how much will it charge per year? We multiply this value by this value, and that's how much it'll cost per year. And we get a cost of $51.03 per year. So that's how much it'll cost to run this fan for the entire year. The pressure is going to be what the manometer says, and so I'm going to put that there, and then it also says some fun facts about maintenance. So I'll put that right on the tube here, right here.
After we installed our radon mitigation system, we had the radon in our basement tested again for levels. And so this time, ventilation type, we have a central fan going and serving the radon system, or serving our house. And so we have a minimum of 0, which is great, an average of 0.4, and a maximum of 1.1. That's a lot better than what we originally had, which was a maximum of 19, an average of 8.6. And then I forget the minimum. I think it was maybe 1.6. And then temperature-wise, the first test was done in September, and now this test was done in January. So the temperature is different. The first test was done around 70 degrees or 75 degrees Fahrenheit. Now we're at around 51 and 55. The relative humidity is lower. Now this could be because the temperature is lower, so the amount of water in the air that the air is capable of holding is lower, so the relative humidity is lower. It also could be due to the installation of our radon system. So it could be that we were able to reduce the amount of relative humidity in our basement, or amount of air, or amount of water in the air, because we also sealed our French drains. So there's potentially less capability for water to enter our basement. And then it looks like atmospheric pressure stayed around the same. And so every hour, the following information was tested: radon, air pressure, temperature, humidity. And it looks like it's all staying relatively constant. Temperature-wise, we have a fluctuation, again, of around 8 degrees Fahrenheit. And then I know that the dashed line is all over the place, but now our boundaries are 0 and 1.2. So before it was 0 and 19. Now it's less movement. I know that this graph looks like it's spiky, but really we reduced our radon levels significantly.
So this is it in the rain. I'm going to bring it close so you can hear it running. That isn't water coming down the spout, that's water coming down the downspout here, not this radon system.